So let's discuss the concept of how AC circuits work, right? So how does the voltage source work? So in the DC circuit, obviously you have a V equals DC, but this is your AC. So this is the AC, the waveform of the AC. And these things have certain meanings, right? So here in this equation, you have Vs, which is your AC line, equals Vm cosine omega t plus phi, okay? So Vm is simply your amplitude. Okay, and we'll discuss that in a minute what that is, okay? Your cosine, when you see a cosine or sine, right, it really means oscillation, right? Oscillation. So something is, repeating itself. A pattern's repeating itself. It's oscillating. It's a wave, right? Your omega is simply your angle. Now, do not be confused with this, right? So this right here is resistor, right? But we're not a resistor. This is a small omega. So this is not your resistance. This is a small omega. And your small omega is angular frequency. Okay? T is time. And phi is phase. It's your phase. Okay? So, how do we first analyze this? First, this is simply amplitude, that's straightforward, oscillation straightforward, okay? So we're going to discuss that. So if we look at your graph like this, let's just graph your AC circuit. It looks like a wave. This is your oscillation. This is your amplitude at its peak. This is your oscillation, okay? What is this angular frequency? Well, frequency is how many times it crosses the x-axis within a certain time, okay? So how do we do that? Well, omega, your angular frequency, is equal to 2 pi f. So anytime you have a pi, right, it means it's moving something in a curve, right? It's curving out some sort of line, okay? So f is frequency, it's linear, and pi is simply moving it into an oscillation form, right? So it's moving in a circle. Your f in the United States, anywhere you go with electricity, is 60 hertz, okay? And this is true for USA, this is true for Canada, and this is true for Mexico, right? Now, in other countries, it's 50 hertz, right? 50 hertz. So most of the other countries, it's developing. Or their electrical infrastructure. So they have an older electrical infrastructure. All right. So for instance, let's say parts of Africa, Asia, they use the 50 hertz. India has the 50 hertz, right? They're developing countries. The older electrical infrastructure comes from the old British. So France has 50 hertz, okay? Now the corresponding voltages are the following. 60 hertz generally. So generally speaking, if your voltage is at 60 hertz, like your electrical foundation is at 60 hertz, so your Vn generally is going to be anywhere ranging from 100 to 120, right? It kind of depends. But generally, 100 is equivalent to 120 in the AC range, okay? There's not much difference. And it's at frequency at 60 hertz, right? So anytime a country has 110, 120 in your plug, this is your plug, and then it's at frequency at 60 hertz, okay? So in your house, if you have 110 voltage, 120 voltage, your frequency is 60 hertz, right? The other parts of the world that operate at 208 volts, this is volts by the way, to 240 volts, it operates at frequency at 50 hertz, okay? So when you go to the developing country, or let's say France or Spain, they operate at 50 hertz, their corresponding voltage is 208 to 240. If you're in the United States, Canada, Mexico, or some other countries, they're at 60 hertz, then your corresponding voltage is 100 to 120, okay? Now, these voltages here that coming directly out of your plug, we're not talking about your washer, dryer, high voltage. This here, right, is called line voltage. Okay, it's a very important term to know. Okay, now we go back. Okay, let's look at our equation real quick. Now, given this format, we will analyze this equation. We will analyze the following. V max, amplitude, V peak. Sorry, let me rewrite this for you. V peak, V peak to peak, Vrms, V measured, V average, okay? Phase, our frequency in the US, because we live in the US. And we have angular frequency, okay? So here's the following. This is the equation. So this matches this Vm, cosine matches cosine, omega and t, and then phase is 30. So let's analyze this. What's Vm? Vm is V max, right? Sometimes it's M, sometimes it's max. That's 120 volts, okay? So where's my Vm? My Vm is right here. This is my max voltage, Vm, and that's 120 volts, okay? 120 volts. What's my V peak? What's my amplitude? My amplitude is also 120 volts. So these two mean the same thing. What is my V peak? V peak is simply, I come here, I draw an arrow, I go to the top, right? That's also my V peak, which is V max, which is 120. So they mean the same thing. Okay? Mean the same thing. So max, amplitude, V peak mean the same thing. V peak to peak. What is peak to peak? Peak to peak is here. And it's kind of an estimation, okay? And this is your peak to peak, okay? So this whole thing here is peak to peak. What is that? That is double 120. Even though this says 120 volts here, this is double 120, so this is 240. Okay, 240. What is Vrms? Vrms is roughly 70% of your peak voltage. Okay, 70% of your peak voltage. So how do I calculate 70% of my peak voltage for a we want to do this in our head. You take 120 times 0.7, and you get 84 volts. 84 volts here, okay? So this is 84 volts. Okay, so if I measure this, even though the peak to peak, peak is 120, I get 84 volts. What's my average voltage? Average means measured, which is also your 84 volts. Means the same thing. Okay, so these three are the same thing. And this is 84 volts. 84, 84, 84. Okay, what is my phase? My phase is here. See that phase? That means it's this phase, which is 30 degrees. What is my frequency? Frequency is always 60 hertz. That's something you should know. What is my omega? Omega is angular frequency, 2 pi f, right? So that's 2 times 3.14 times 60, which is what? 376.8. Okay.